This is Mr. V. Welcome to this video series on location on Earth. This video is going to be on how we know the rules that we use for distance on Earth are true. So, a piece of information. The average radius of Earth is about 6,371 kilometers. So from the center of Earth to the outside is approximately 6,371 kilometers on average. At the equators it's a little bit bigger, at the poles it's a little bit smaller, but on average that's the value. So the radius of Earth is 6,371. So our radius is 6,371. And if you remember, the rule for circumference, or the distance along the outside of a circle, any circle, the circumference, we know is 2 pi r, 2 times pi times r. So 2 times pi times r is our equation, and we know a value for r, which is 6,371. So we can put that into our equation. So 2 pi times 6,371. And we put it on a calculator and get a number. But we don't want to finish there. We don't want to know the circumference, because we're going to use this rule to figure out how to use longitude and latitude to tell us a distance. So what we want is to know what 1 degree equals. Now if we look at a circle going all the way around, we have 360 degrees. So going all the way around is 360 degrees. So this circumference equals 360 degrees. So I'm going to put that on this side now. I'm going to replace circumference with 360 degrees. And we want 1 degree. We want to get 1 degree. And to get 1 degree, we divide 360 by 360. So I'm going to divide both sides by 360. So the calculation for 1 degree is 2 pi times 6,371 divided by 360. And when you put on your calculator, you're going to get approximately 111.2 kilometers. Now, this works for any line that is a full circle around the Earth. So this applies for either the equator or a meridian, because both of those go all the way around the Earth. What about our parallels of latitude? We need a different rule. So here we are. These parallels of latitude, as we go up on the world, these circles are going to get smaller and smaller and smaller and smaller until right at the pole they're going to be practically zero. And so we want to know what the radius, so the flat radius, is along each one of those circles, so we can then figure out what 1 degree on this circle equals, which will be a little bit smaller than 1 degree on the equator. So if we take a slice out of our world, this is what we'll get. We've got our radius of Earth here, we've got the surface of the Earth, so all of these points are the radius away. And we're going to pretend that this is where we want to measure our distance. And so we have this triangle. And what we want to know is figure out what this new r is. Now to do that, we're going to use a little bit of Pythagoras. Sorry, not Pythagoras, trigonometry. And we know from SOHCAHTOA that when we have the hypotenuse and the adjacent angle, we have cos. So I'm going to find cos of my angle equals the opposite over the hypotenuse. Sorry, the adjacent over the hypotenuse. The adjacent in this case is the radius that I want to find, divided by the hypotenuse, which is the radius of Earth. I can now rearrange this for r by multiplying both sides by 6,371. So I'm going to get 6,371 times cos of theta, which is the degrees latitude, equals r. Now again, if I take circumference equals 2 pi r, and we know that the circumference is 360 degrees, 2 pi, we know that the radius now is going to be this calculation, so I'm going to have 6,371 times cos of theta, and again I want to find 1 degree, so I'm going to again divide both sides by 360. So 1 degree is going to be 2 pi times 6,371 times cos theta divided by 360. And we've seen this term before, 2 pi times 6,371 divided by 360. That's the same thing we had over here. 2 pi times 6,371 divided by 360. And we knew that that was 111.2, so we can simplify this to become 111.2 times cos theta, where theta is the degrees latitude. So that's how we know that these two rules are the rules that we're using.